Hello, everyone. I'm probably on stream now. I don't know whether I'm actually live at AIIDE or not, but I'm going to wait until I get a chat message before I start talking. Man, this delay is going to be awkward because I'm going to be sitting there staring into the distance while I wait for a message. I'm live. Excellent. Okay. Sorry for all the awkward waiting. So before I kick off, let me just say sorry that I'm not there. I had planned to come. I haven't been to conferences for a while, but a couple of health issues meant that it wasn't a good idea. But I promise I am going. Nope, it says I'm okay. Okay. I am going to be at events in 2018. I may see some of you before the end of the year even, but I have missed you all. Thank you for bearing with me, and sorry I couldn't be there now. Coming for you live from Germany with a kind of ski resort-esque background behind me. But okay, let's do a talk. I'm going to switch over to these slides now and make them big, and hopefully this will look okay. Okay. My name is Michael Cook. I am an AI researcher at Falmouth University back in the UK, even though I'm at Germany right now. And today I want to talk to you about a vision paper I wrote for EXAG called A Vision for Continuous Automated Game Design. So part of this talk is going to be talking about how I got to where I am, the research that I've done, and then how that's led me to writing this paper. I don't cover everything that's in the paper, but it's sort of like a turning point for my research and a lot of the things I just sort of think about generally. So back in 2010, I started as a PhD student at Imperial College, and we sort of set ourselves this question of, can a computer automatically design games? And I worked in a field called computational creativity at the time, which you'll see will factor in later. 5 years later, I published my thesis. The answer to the question was yes. But it took a long time to write that into a document, it turns out. And there were kind of a number of versions of Angelina that we went through in order to get to this point. So I don't want to go too deep into it because I know I do this in like half my talks and it's super boring, but I just want to go through them because, especially for this talk, it really contextualizes everything that came afterwards. So the first version of Angelina I built made games in HTML5. As you can see, there were no themes really, they're just blobs moving around on the screen, kind of arcade style games, very simple mechanics. And this is sort of the beginning of the project. This is sort of technical stuff. What does it mean to design a game? And this was where I started with this idea of simultaneous evolution and in particular co-evolution, and the idea that all parts of the game should be designed at the same time. And this kind of innocuous decision had knock-on effects for the entire of the project, as we'll see. A couple of versions after this, and the versions are never actually numbered. They were completely separate projects in many ways, but they had this sort of core theme, and I had to number them later. So don't try and remember these numbers because they don't really mean anything. But then I started working in Flash and a library called Flixel. So we built 2D games that look a bit like this. And they had Metroidvania-esque aspects to them. So there would be power-ups you would pick up, and they would modify the game, and Angelina could decide exactly how they modified it. And in particular, the third version of Angelina introduced theming. So it would get web data about news articles, current events, and it would try and interleave that into the game, usually in kind of a clumsy way, but occasionally in kind of interesting ways. And it was also the beginning of Angelina framing its work. So talking about why it had done what it did. And for some of you, that is not a particularly interesting goal necessarily. The interesting goal here is to design a good game. No one cares why you did it. But for computational creativity, this is really important. And this will definitely come back later. Then, if you've ever tried to track down all the versions of Angelina, you'll find that there's just some that sort of don't exist. But there were a bunch of offshoot projects which are worth talking about here. And this was when the tensions began to come into the project, because I wanted to look at more technical problems, more deep technical problems. So I did some work called Mechanic Minor. And the way Mechanic Minor worked was it would design game mechanics by actually individually editing like lines of code and playing with variables inside the game. So it would find like the gravity variable and start messing with it and seeing if it could create a game mechanic that used the gravity of the game or whatever. And this was really exciting stuff. It was really interesting, and the system could do cool stuff. But the problem with it was that it couldn't be integrated into Angelina. Angelina was making games in like 4 to 5 hours, and developing a whole mechanic in that time didn't really make sense. There was just so many like structural problems, especially because the base idea that I had was like the whole game should be designed all at once. You should design the levels and the rules and the theme all at the same time. So it was like one of the things I liked the most, but it kind of got left by the wayside. And then I moved on to Angelina version 5, which is it's probably the one, if you've heard of any of them, this was probably the one you've heard about. It worked in Unity, it built 3D games, and the aim here was to focus on the culture of game development. So I was very fortunate Angelina got some press coverage before this point, and I was really interested in other people's reactions to it. So researchers' reactions, journalists' reactions, gamers' reactions, the general public's reaction. Like all of these people reacted in different ways. And because we were interested in building software that acted creatively, its perception in society is a big part of that. So Angelina version 5 was like, how can we push those aspects? So it entered game jams, and it was designed to be more independent and focus more on the creative and theming things. And so, yeah, it was like the first AI to enter the Ludum Dare game jam, which was a big deal, and we did some fun stuff where people didn't know we were entering, and like there was some really interesting responses to it. It was really fun. It was a nice way to end off my PhD, and that was basically the last version of Angelina. So let me briefly explain to you the structure of Angelina, because all versions had the same kind of internal structure. Oh, too far. There was a pre-design phase. So this would happen before Angelina would start actually designing the game. It would sort of configure itself. So maybe it had to go onto the Guardian website and grab a news article, or it would think about the theme input. So for a game jam, you would get the game jam theme in, and it would have to do some analysis, or it would set up some parameters for itself, that kind of thing. And then the actual game design would take place. And what you had was a co-evolutionary system. It's not really important that you know how that works, but the idea is that you have all of these different aspects of a game, like the level design and the rules, and they're kind of working on their own. They're designing themselves, but when they want to know, is this a good level design, they would ask the other aspects of the system for their best current example. So give me the best rule set you have right now. And the rationale behind this was I didn't want any particular aspect of the design to be in the lead. So a good level design could inspire the rules design, but at the same time, a really cool idea for some rules could inspire the level designer. That was the theory. In reality, there were loads of problems with this approach, but it was a good theory. It was a good stab, and it produced some systems. The systems did things, like undoubtedly. And then after that, there would be a post-design phase, and most of this is sort of computational creativity specific, but that was things like naming the game, compiling it. In some cases, it had to like compile the actual game, and also talking about why it did things. So why does the game feature photos of Barack Obama, and why does he look so happy in them? And this is really important for proving to people that the system knew what it was doing and it wasn't just random chance. So you can see some of those examples on the website if you're interested. And then it would release it, obviously. So what were the problems with this? So some of them were, like as time went on and I wanted to add other elements to the system, I found it increasingly difficult to do so. So you would have things that needed a lot of bandwidth, like a lot of thought, compared to other aspects. So for instance, level design could really do with like lots and lots and lots of iterations in between each change to the rule set, because a change to the rules was like felt more fundamental than a change to the levels. And so there started to be like tensions internally between all these different design elements. And then there were other things like mechanic minor, where ideally you didn't really want to be doing it while designing a game at all. You wanted to do it before you designed a game and then use it as part of your game design. But I just couldn't reconcile all of these different things. Like the system was becoming this unwieldy Frankenstein thing of all of these different ideas and frameworks plugged in together, and most of them didn't fit. And that was one of the reasons why it was sort of necessary to restart it occasionally, because I wouldn't want to come at it from a different angle. So that was one problem. From the computational creativity side of things, I had another problem, and that was that people could only go with me so far in believing that Angelina was even on its way to being creative. Obviously, it's not a particularly advanced system, but the suspension of disbelief stopped somewhere. And one of the problems was that I was in control of it. I pressed the go button, and I wrote all the code. That's another thing people hated, and it just felt like I was in charge of this system. And the other problem was Angelina existed on my laptop. People would often ask, like, where is Angelina? Is it on a server? Is it a robot? Is it in my laptop or whatever? It was, a Unity project or whatever inside my laptop. But there was no way to actually engage with Angelina. You would only see, like, the shadows of its creativity through the games that it made. And then you would infer what Angelina was like from that. And there were a few other cool ideas that I wanted to do, but I couldn't because Angelina would make a game and finish it in 4 hours. And in 4 hours, you can't do much stuff in the real world. So one example was playtesting with humans. We couldn't send games out to human playtesters because Angelina would only be working on it for 4 hours. And there wasn't enough time to get feedback or incorporate it into the design, or even for the playtesters to check their email and know that they needed to be playtest something. And this is kind of a side note, and it's not actually in the paper, but I think this is particularly common of computational creativity systems. So my supervisor made a system called the Painting Fool, and there's been computationally creative chefs and composers and all kinds of stuff. And in many cases, they tend to mirror the person who designs them. Not in all cases, but in some. In 2010, I didn't know anything about game design, anything at all, and neither did Angelina, and so we were kind of bumbling along. By 2013-14, I was entering game jams regularly, and I was engaging with communities of game developers, and I gained a lot from that, and it changed my perception of how game development works. And so when I built Angelina, it sort of started to move towards game jams as well. I had to enter game jams and socialize with people and interact with people. And now in 2017, I've changed again as a game designer. I'm now working on a big single commercial game release. It's the biggest thing I've ever made. I do some work on it. I stop. I have a think. I kind of work on something else for a while. I get influenced. I playtest. I work with other humans. And so you can see how the things about game development that are on my mind have influenced the things that are on my mind about my research as well. This is a side issue, but it's just something I've noticed as I've reflected on the past 7 years. So now to the actual title of the paper, 11 minutes in. But it was just necessary to kind of set the scene of what I've done and what the problems are. So here is my proposed solution, and here's what I'm taking forward for the new version of Angelina, and kind of how I think automated game design should be done, really, thinking about it now. So this new proposal for how to build automated game design systems has a few properties that are important. One is that they don't have a beginning or an end anymore. They just go. They just move forever. And that's because they're not turned on to make a game. They're just doing things. Like, it's doing level design for this game right now. And then at 6 o'clock tonight, it might have given up and it might be working on another project or reading Twitter or doing something else. It's like a series of activities that are interleaved with one another, and there's no need for it to end. You can switch it off to save your electricity bills, but other than that, The other thing is that they're now like a sum of many different parts. So, and I kind of just mentioned this, but it's now not that you just go through everything in one order and then you're done. It's that you can move between modules, and you can move between projects, and you can move between tasks. And this has a number of benefits, both from a research standpoint and also an engineering standpoint. And I'll mention those in a minute. And most importantly, and kind of counterintuitively, when you talk about advances in most technology, or most of the advances you'll hear talked about at AIIDE for the rest of this conference probably, you talk about things being faster or better or more efficient in some way. I realized at some point that I was going to gain a lot if I slowed Angelina down, and not like a little bit, by like a factor of 10 or 20 or 100. I've slowed Angelina, the time it takes to make a game, down massively. And the reason for this is that it gives you so much space to do stuff in. And I'll talk to you about the kinds of stuff that could be in a minute. But first I want to show you the structure of what Angelina looks like now. So now it has a database of things that it's working on, projects, active projects. Some of them abandoned, some of them finished. It's not just one game, it's got a whole list of them. And it's also got a list of design modules. And these are kind of standalone and cut off, and I'll talk about that in the next couple of slides. But they might be for level design, they might be for designing the front cover of the game, or inventing new ideas for game mechanics. And then it goes through, it picks up a project, it looks at what active tasks it has. Maybe it's designed levels for one game, it puts that down, it picks up another game, it looks at the rules, it releases a game. And all of these stages have side effects, so they might write back into the database. So designing levels will update the active project, for instance. It might cause projects to be abandoned if it decides they're not very good. That's fine, like that's part of the process. It's one of the reasons why it's slower. And it might involve interactions with the real world, so talking to people, writing blogs, releasing games, that kind of thing. So the way these projects work, and I go into a little bit more detail in this in the paper if you're interested in like the syntax and stuff, but Angelina is now a database of these project objects, and they are written up as JSON files, and inside them they have references to other JSON files which are games themselves. So games are now like JSON scripts that are interpreted by a player. And the important thing with the projects is that they contain like a version history, so that Angelina can look back at the changes that it's made. If it improves the game design, for instance, that might be really useful to tell people sort of about the history of this game's development or something, which could be really valuable for framing. I use a custom language which is not quite PuzzleScript, it's not quite VGDL. There is a reason why I've pig-headedly kind of not used either of those things, and it's about some planned research I have in the future where Angelina will kind of do some of its own editing and stuff, but it's not archaic or anything. Like if you want, you could probably even convert pretty easily to VGDL. And yeah, the way these games are kind of run are sort of like cartridges. They're text files that you slot into a player. And that's nice because not like a human player, as in like an application that plays games. And that's nice because it allows Angelina to maybe one day directly edit these rather than having to worry about, like I've tried editing code directly before, or it also makes exporting much, much easier, which was like, just from a technical standpoint, was one of the major headaches with Angelina in the past. So these tasks are that it moves between are completely standalone, and they have quite strict interfaces. So for instance, the level design task takes a project and a couple of parameters, and then it tries to design a level for it. It's not completely general, by the way. It can't like design a level for a real-time strategy game and a level for an RPG or whatever. Angelina is restricted at the moment to certain kinds of games, but it's fairly general for our purposes. It's like a puzzle script-esque thing. And the good thing about this is that it can be reused. So with just a few more parameters, it can have like a small time kind of exploratory thing or a deep dive into level design. And this can be all kinds of stuff. These tasks could be artistic in nature. They could be social. They could be technical. So it's very modular, which is nice. But there are some nice benefits, not just because, like, modular systems are great because we can just write a small module and we don't have to worry about how it intersects with the rest of your code base. That's great if you're a software engineer and stuff. The really nice thing about it is that it emphasizes persistence. And I think this is actually very important for automated game design research. So because all of these modules are separated, they need data to be fed to them. And that means the data has to exist somewhere else, in theory, unless you've got like direct code calls going on and you're sending over huge amounts of objects and stuff. But most of the time it's going to mean that, especially if you're moving between projects, you need to like save the state of a project or save the past of a project or write down what you intend to do in order to tell the task. So like, I need to design a level for this game that has these properties. And this is really useful because it increases your reliance on this sort of persistent data. And that means that there's more of the system left behind when it's not designing a game. And from a computational creativity perspective, that means that the system has more to talk about because there is more written down, there's more history, there's more archives. And it also means that for the first time, the system exists outside of a game. So Angelina is sort of the remnants of all of these projects and all of the margin notes that have been scrawled into the edge of its code base and things like that. That's what the system is now. Before, the system didn't really exist, but now people can kind of connect with this thing that the games are gestating within, kind of. Like all of the records of tomorrow I need to test the levels on game XYZ, that kind of thing. The other thing, I've kind of talked about the perception thing, but the other thing is that by slowing the process down and forcing it to move between different tasks, and for some of these tasks, they can take a day now. It doesn't really matter because we've got all the time in the world. We can also do the things that I talked about earlier. So we can have human playtesters now. On a Monday, Angelina can push a build to playtesters, and then it can put that project back in the database and not work on it anymore. And it can take another project out if it wants to and work on that, or it could invent some game mechanics or whatever. And then when that feedback comes back in, it can resume work on that project. So just by acknowledging the fact that it's going to take time to make these games and not worrying about how quick I can do it, I suddenly just create all of this breathing space where all of these new interesting things can be done. And like the dream is that Angelina will put a game away in January because it can't design any levels anymore. It's come across this design problem. And then in March, it will come up with an idea for a mechanic, and it will realize that this will actually solve the problem with that game that it couldn't finish, and it will go back to that project. That's kind of like the dream scenario where it's got this great story to tell about this breakthrough moment that it had. Now, I don't know whether that will really happen, but in my head, like the continuous nature of the system allows this to happen. The system is also more observable than before. And this is partly because it's not just going through things step by step. This is also because of the way I've chosen to design Angelina, but this is not necessarily unique to continuous AGD, but it's really important for Angelina itself. And that means that people can watch it do things that they maybe don't, that the AI systems do all the time, but people don't think of AI systems doing. So it's very common for an AI system to throw away a result. But now you can see it do this, because on Monday, I will look over to the laptop and it will be designing a game, and then on Tuesday it's abandoned that game, and I can even work out why. Right now I can't actually get Angelina to verbalize why, but that will be possible in the future, as Angelina will be able to look at the version history of this project, understand why it thought it was a good idea, and then write about why it ended up not being a good idea. And that has some interesting implications that you probably can guess, but I haven't quite talked about yet, because I don't want to announce it until I know that it's technically feasible, but I've implied it heavily throughout this talk, so you may have already worked out what it is. Anyway, that's for the future. So the things I'm working on right now are, if you have a list of tasks and a list of projects, how do you actually get the system to decide what to do next? So to avoid this problem I had way back in my PhD of, well, I don't want to prescribe what Angelina should do in order, I need to get the system to have some reason to independently go to one thing or another. So at the moment, I'm thinking that there's some kind of notion of progress possible, where a continuous system can look at the projects it has and gravitate towards the ones that seem to be solvable. And what I mean by that is that when it tries to, say, design a level, it successfully does it, and it does it with quite a good high level of quality. Whereas if it's constantly failing on one particular project, this notion of progress might decay, and it might put that project away and come back to it later. Framing is also a massive issue. What should Angelina tell people about, and why? Before, it wasn't a problem at all, because Angelina would only talk about games it had finished, and it would only talk about them once it had finished them. And so you didn't hear from Angelina very often. But if Angelina now started tweeting while it was developing games, we have to be really careful that it doesn't just tweet about everything it finds. It needs to know that this was significant in some way, or this was interesting, or it's worth talking about. And I know that lots of the talks, lots of the slides in this have been focused on computational creativity, and that's because that's my wheelhouse, and I know lots of you are interested in that. But I have also been thinking about applications to industry. So if you were going to put a continuous game designer in an indie studio working with people and helping them, what would you worry about? How would you change the system? I think, first of all, you'd want it to be more communicative in the sense of participating in a Scrum meeting every morning, not literally, but that kind of information. And maybe you wouldn't worry so much about whether people could watch it work. Maybe you'd focus more on being able to neatly specify tasks, but that's kind of an active area for me. I'm still thinking about that. In terms of really far-fetched stuff, I'm still thinking about real-world meaning, which is still really hard. I'd like to work with humans, playtesters, maybe even hiring some people like musicians or artists, maybe, get a small budget and let Angelina have independent control over who it hires, and whether it accepts the work, whether it gives feedback on it or whatever. So that's still there. So quick summary, then I'm done, honestly. So before I told you about Angelina, it was this automated game design system, and it was always contained within these games that would grow and then explode, and Angelina wouldn't be left anywhere. Like, you couldn't see where Angelina was now, you could only see where it had been in the past. But now we've managed to move to a different model, where the games are contained within Angelina. Angelina is a system, finally. It has this persistence, and that's because we now have this continuous system that is always moving between tasks and never disappears, really. It's always growing, it's always learning, and you can see that happen very clearly in the data that it leaves behind. I'm also now going to be proposing that everyone slows down their systems. They make them take more time. It's not just for people making weird creative stuff, I think. I think it makes sense in general to give yourself more time and allow your systems to think and tackle problems that normally you would say were too difficult to do if you were worried about doing it within 3 hours. Like, say it takes a week. It doesn't matter. If the results are amazing, that's fine. Like, game development takes a long time. And yeah, modules are really great. They've made it much easier to design an AGG system. Everyone should have a go at that if they haven't already. And Angelina's back, and I've really missed having Angelina around, and that makes me very happy. So you should see more about that from me soon. And that's all I've got. Thanks very much. If you want to follow Angelina, we both have itch.io pages. Angelina's is pretty bare right now, but it will have games on very soon, and we're on Twitter if you want to talk. Thank you. What I'm going to do now is go back to my face. There we go. So I'm on the YouTube chat, and if there are questions, you can type them into the chat. And if there aren't, Joe, just let me know, and I will stop streaming, and you can take back control of the stream. Thank you. This is awkward, isn't it? I'm sorry. This was a bad setup. Thank you for letting me stream. Does Angelina think about surprise? Not right now, but that's actually where I'd like to go with the novelty thing, is because it's you mean prediction. Okay, yeah, that's actually very interesting. So it does not predict design changes, and actually right now the base implementation for some of the modules is actually extremely basic, and it wouldn't even have the capacity to predict what's going to happen next. But I would like to do that kind of thing. I am planning to have surprise in the context of novelty, I guess. So it keeps a record of everything it's seen before, and so it can kind of assess, like, how different is this thing that's just happened in the context of everything I know about game development. And one interesting thing I didn't mention in the talk is that because I have this more open way of specifying games, is Angelina can play games designed by humans or even by other systems now. So I'm hoping that it will be able to maybe build up an understanding of how it thinks about games so that it can be surprised by things that happen later. But the prediction question is interesting. I like that. Sorry if there's a massive delay. Feel free to tell me to stop streaming at any point. How do you intend to capture meaning and theme beyond asset choice and skinning? That's a great question. So I'm planning to dig into some of Mike Tranor's work on the Game-O-Matic and use some, sort of pre-written concepts of like mechanical ideas, I guess. But this is, again, a great thing that we can do now. So I can now have Angelina have a module that is figure out what a game mechanic means. So it makes some games, and it tries to maybe extend using a metaphor. It extends an existing thing that it knows about, like X over Y means kill, and then it tries to use a metaphor to guess at what another mechanic might mean, and then it can send things to playtesters and say, listen, I've tried to convey something here, can you tell me what you think it is? And then it can maybe learn from this. So I'm hoping that maybe it might even be able to recover, like invent some of these ideas itself using some back and forth discussions with human beings, maybe. Whether or not that's considered independently creative or whether it's just milking it from other humans, that's a debate I'll have at ICCC at some point loudly in the audience. Okay, I'm being cut off. That's no problem. Thank you so much, and I'll talk to everyone on Twitter. But thank you so much for having me, and I will see you all at some event this year or next. Cheers, everyone.
Hi everyone, welcome back to Utah. I hope you enjoyed your detour through Germany. We're starting to get a bit of glare through the windows. Hopefully we'll fix that after lunch. Hi everyone, welcome back to Utah. And I already muted it. And now we've got our next talk. So you want to come on down?
Right, if you're ready for me.
Yeah.
Okay. Hello, EXAG. Hello, everybody. Hello, the home audience. I'm here to talk about, well, so first off, I'm Joe Osborne. I'm at UC Santa Cruz. This is work with Benjamin Samuel, who's now at University of New Orleans, and my UCSC colleague and advisor, respectively, Adam Somerville and Michael Matias. We're going to talk about general role-playing game playing. So the takeaways from this talk are that role-playing games are an interesting domain that offers some particular challenges. Writing an AI that's capable of playing a specific game is not so bad, but the general case is just extremely tough. And in order to accomplish it, we'll need to make some advances in core areas of AI, like common sense and goal reasoning and other domains. That said, we do have what we need to start making progress in this area. And if we are able to achieve even parts of our goal, this could support new types of game design, new types of design support, in addition to being of interest from a general purpose AI standpoint. So a little background on general video game playing. It's been mentioned a couple times already. The general video game AI platform is great. It supports lots of different games, largely in sort of like a puzzle or action kind of genre. There's a lot of these games. There's a very active community with a lot of active competitions, and generally these are games that have maybe like one screen and one like game mode. I don't have a better term for game mode than game mode, but we'll talk a little bit more about modes in a little bit. And these are really good at evaluating generalized approaches to like world model learning. So can an AI understand what action it ought to take in this domain? This is a huge oversimplification, and GVG AI is good for teaching lots of other things too, but the sort of like main track, I think, emphasizes this kind of learning. So what am I talking about when I say RPGs? Like, how are RPGs different from this GVG AI domain? I'm mainly talking about games like Final Fantasy or Dragon Warrior, where you've got these like super long game with like really strongly multimodal play, right? Like you're navigating on a map, you're fighting in a battle, you're dealing with menus, you're managing resources and equipment. It's like customizable characters. So it's like a really complex game, and you can't use the same techniques you'd use for GVG AI for a game like this. I think they just don't scale in this kind of direction. So these are typified not only by having lots of different game modes that you're in throughout play, but by long-term and short-term concurrent and hierarchical player goals, which are kind of formed on the fly as the player learns more about the situation. So you might have a high-level goal of like beat the game, and you're always adding more steps onto that process. At the same time, you might have goals related to getting your characters stronger so that they can accomplish the next objective, or getting enough money so that you can buy the equipment that makes your characters better. And these things are like 10 or 20 or more hours of play. So naive like search approaches just can't do it. It's just too long. It's too big. They also lean really heavily on cultural knowledge. And by this I mean like some enemies look like they're made out of ice, and some enemies look like they're made out of fire, or some are dragons, or like different types of terrain might be like a switch or a door. And you need to know as a person, you know that maybe there's a keyhole needs a key, and a door might be active. A switch implies that there's a door or something somewhere. You also need to know about things like that like steel is harder than iron or something like that, right? Plus, there's all this fantasy domain and game-specific knowledge, like lore, if you like. There's several dozen of these types of games on this like Nintendo NES and Super NES, and there are also like mods for these games and randomizers that can produce new examples, sort of on demand. But there's also like a huge variety of like RPG Maker games, and there are many platforms for making these types of games. And I also think that learning how to do these games well will generalize well to other sorts of games that share some similar structures. In this work, we're focusing on some NES games because we already have some good feature extraction stuff for NES. But this is like without loss of generality, NES RPG playing. So from some perspective, RPG AI is like pretty simple, right? Like in combat, if you have enough HP, attack, and if you don't have enough HP, heal. At a larger level, it's like I'm not done with the game yet, so I should go to the next town and then like get stronger until I'm ready for the next dungeon. And if I like need to heal up, I can go to the inn in the town and then come back out, and until I get better equipment so that I get stronger, and then I can go to the next dungeon and then beat it. So you can imagine some expert system that's really good at playing some particular game. And any given component of an RPG system, like any given system like battle or navigation or menu navigation or like shop, like using shops or equipping items on your characters, like these are all pretty simple if you know enough about all the other systems in the game. The interesting parts of RPGs are really like in the interfaces between these complex, like these individually like somewhat simple systems. It's for players, I think, and I'm going to assert this without proof, that the enjoyable thing for players is like learning how these systems interact and how that like has some friction and like conflicts with the story stuff that's happening in the game, right? Like the text that you're reading, the cutscenes you're watching, the character animations that are going on. I think that both of those working in concert are what give you the sort of like engaging experience of playing one of these games. So it's the point of the slide is just that the interfaces between systems are really important. Generalizing to a bunch of different games, a bunch of different RPGs is super hard. So you have to learn on a per game basis, like how are the menus structured in this game? How do I move between the menus? What are the different game modes, like walking around on the map or being in a battle or something? You have to learn the goals of this particular game, like what you should do next, like what short-term objective, like what kind of equipment you should try to buy next, where to go next on the map. Like if somebody tells you the name of a place, you should know like how to map the name of the place onto a location in the game world. You have to learn that the characters in your party are not interchangeable, that they have some differences that you should take advantage of, and that enemies are not like all equivalent, that some of them have different weaknesses and things like that. And you need to know something about the like math in the game, right? Figuring out the math, reverse engineering these equations about like how does the like attack value of a sword relate to the strength value of the person wielding it and the defense value of the target. And RPGs have this like super long time horizon, right? Like you can't plan a whole game in one go at like 60 frames per second. It's just not tractable. And a lot of approaches to finite horizon planning might have trouble with these like multiple levels of long-term goals. So you got to introduce some new techniques to handle these kinds of issues. The big issue that you might have caught onto is this cultural knowledge thing, right? Like interpreting hints is really hard. Even if it's like an obvious hint for a person, it might be really tricky for a computer. And combat features a lot of hidden information, non-determinism, probabilistic effects of actions, and a lot of different parameters that might be involved in these equations. Moreover, games have a big part of enjoyment of RPGs is these game-specific gimmicks, right? Like it's like a different magic systems, or like a limit break or something, or special rules for certain bosses or certain ways of moving around the map, like mini games, which are maybe GVGDL. GVG AI-like minigames embedded in this larger RPG. And different games, of course, have different character statistics and equipment, although some are shared and some stuff should transfer. I think one of the most interesting sources of challenge is that role-playing games have a lot of what are called symmetries in the state space. So if you move up and then move right, it's basically the same as if you moved right and then moved up most of the time. Or if you equip an item and then immediately unequip it. Like this is an equivalent state to what was there before, but stuff happened in the meantime. Identifying these kind of symmetries automatically is really challenging. It's really interesting. It's also the case that some of these symmetries are quite contextual. So it might be that for the sake of combat AI, having full health at one time and having full health at another time, like basically the same state, or having full health or then having like 80% health, still basically the same from the perspective of the combat AI. Even though all of the other game state, like economic state, position in the world, all that stuff might be different. To me, this is like, as a software verification person, this is super interesting and could have huge ramifications if we're able to do it for like modular software verification. But that's not the only reason to do general RPG AI. I think that there are some useful overlaps with the planning community, especially like goal reasoning and hierarchical planning, to do this planning at multiple levels simultaneously. This issue of learning a lot of different sub-problem specific knowledge representations seems really important. I think a lot of discussion in the knowledge representation community is around learning like the one representation for the task, but actually we need to learn, like we need to slice it up and treat different tasks with different knowledge representation. And even the like nuts and bolts, like are we currently in a fight or on the map or what? Like that's already like kind of an interesting AI challenge to figure out like how to interpret the current game state. And of course, making progress in RPG playing AI also tells us something about common sense reasoning. Like, we got to know that you should use the fire sword against the ice monster and the dragon sword against the dragon type monsters. You need to deal with instructions that are quite explicit. Like, they're not, they don't even qualify as a hint, right? Of like go south until you get here, then cross and go east. Like these kinds of directions or visual clues, we have to be able to handle those. I think that dealing with combat will be really interesting because it's like finding a nice kind of compact model of a black box system that has non-determinism and probabilistic outcomes. Even in navigation, like often RPG path planning is quite simple because it's like a four neighbor grid that you can just move around arbitrarily, but it interacts in interesting ways with goal formation. So you might want to like intentionally go the wrong way in a dungeon so that you're sure that you get all of the treasures and don't miss any. And so conceptualizing like, how do I know if I'm going to the end of the dungeon versus going down a dead end that might have treasure? The goal for us is to have some AI system that can figure out the mode it's in at a given time and apply some mode-specific strategies, which are either given in advance or learned, ideally, reason about and form these kinds of goals, and reason about and form state abstractions. Of course, this is like the hard part. If you have all that, the actual search problems are quite easy. Like if you look at a walkthrough of a role-playing game, no problem, right? Just like follow the steps and you're good. So it's focusing on kind of a different part of the AI problem than the GVG AI stuff, I believe. I'd like to argue next that general RPG AI, like it's possible to do, even though it's really hard. I don't think it's the same as like capital H hard AI, where it's like human level cognition. Or, you know, in the worst case, if I'm wrong, and if it is, I think that those parts that require human cognition can be sequestered away and just like annotated away, and we don't need to deal with those parts. The rest of the problem is still really interesting, even without like cultural knowledge, for example, as being part of the things that we're trying to learn. And there's a lot of active work right now in things like representation learning, and even the cultural knowledge problem. Just down the road at Brigham Young, there are some researchers working on like automatically figuring out, like bootstrapping text adventure AI by learning object affordances, like what can you do with a rock, for example, from Wikipedia. So using vector embeddings to figure out, like you can pick up a rock, you can like take a rock. So I think that it's not impossible, at least. We can also already, this is work presented at the International Joint Conference on AI last month or 2 months ago or whatever, on learning action game character behaviors. So we can get like design information out of a game. Like, I think that that's kind of the core problem of this RPG AI issue is getting the game design parts out of the game program and then planning on that game design level representation. There are plenty of off-the-shelf text recognition programs, although we show that they do need some modification. They don't just run as is on these like big blocky Nintendo fonts. And we have approaches already for things like menu structure learning, numerical transition system learning, or MDP learning. So like the pieces are there, I think. We also have some really high quality corpora, right? Not only things like GameFAQs, but also YouTube long plays and like videos of people playing games that we could use to bootstrap search. Even for games that don't already have these, maybe it's helpful to like throw a neural net at a bunch of different walkthroughs, because it's possible that like even different games have kind of similar structures. We have some early work we show in the paper on feature detection, like automatic mapping or detecting windows and overlays where menus and stuff might be. So I think that it's doable. If we can do it, it'll have some good effects, right? Like we can make new kinds of video games if we have AIs that can like play an RPG. Last year at EXAG, my co-authors presented a taxonomy of computationally assisted performance, and one of the reasons that one of the like new ideas that they proposed was a game where you play a dungeon master and all of the NPCs traditionally, and the AI is playing the hero, and your job is to give the hero like a satisfying experience, like to make them feel good about themselves afterwards. And it seems like general RPG AI is prerequisite for giving enough authorial leverage to the player to make this interesting. You can also imagine games where you coach an AI how to play a game, which might also be a useful way to get around some of the like capital H hard, like human style cognition that seems to be connected to this problem. If you have these kinds of agents, then you also have new approaches for player modeling or automatic tutorialization or goal recognition or design support. So if you as a game designer write up a walkthrough of your game, you can use that walkthrough maybe as a kind of regression test to show that like when you make game design changes, now your walkthrough doesn't become unachievable. And this also could contribute to AI at large, right? Common sense reasoning, all the areas we mentioned already, knowledge representation, goal reasoning, planning, verification. And it could be useful for assistive technology or for autonomous agents too, for all the same reasons it's useful for game playing. If you'd like to get involved in this area or in these kinds of projects, so we phrased it as like a we're doing work towards this, but what we really want is to produce some kind of community around doing work in this area, because there's just so much to do in so many different parts of this problem. We're doing all of our development out in the open. There are lots of useful like feature extractors and stuff for tile-based NES games, and soon we should expect SNES and some other platforms, working with some undergraduate mentees doing computer vision stuff for that. That said, the repository is in a bit of a state, so do email me if you'd like to get started on this and I can get you hooked up. And we're looking to collaborate with anybody at any level on any of these problems. In that spirit, I'd like to invite you all to consider submitting to the Knowledge Extraction from Games workshop at AIIDE this year. You have literally weeks to get something in. We have a short paper and a long paper track. 15 days is plenty of time to do a short paper. And I'd like to emphasize that, so first, I guess, the mandate of the workshop is to discuss how we get design knowledge out of video games, ideally automatically, and how do we build AI systems that can make use of that knowledge. And we are really open to also like more theoretical perspectives on this. So if you have like a game design framework or game critique framework that you think might be mechanizable, we would really like to see that. We've already gotten a lot of mileage, like I've in my own work, out of things like operational logics and proceduralist readings with Chris Martins and Adam Somerville. And I think there's more theories like that can be really helpful. So yeah, please submit to our workshop. To sum up, role-playing games, I think, are just essentially interesting. They combine a lot of different games into one overarching framework. They're especially interesting because while writing an AI for a specific RPG is not that bad, writing an AI that can handle any RPG you throw at it is super tough. And in order to achieve it, we need to make advances in some key central areas in AI. But it's doable, and we have the tools to start moving in that direction. And doing this could give us new kinds of games to play and new forms of design support that just weren't tractable before. And with that, I'll leave it for questions. Thanks very much.
So just so that the stream can hear, this is asked mostly to hear your answer. Why not just use deep Q learning with screen data?
Deep Q learning, good old deep Q learning. Deep Q learning, I think, does really well when what it needs to know is on the screen. I think that with RPGs, you might have several screens that are identical, but have really different next steps. For example, if you're on the world map or something and you're walking around, there might not be any visual indication that you have maybe like one hit point left on one character versus like all your characters are in perfect health. And those are really different states. So maybe you put in some recurrent stuff and you're able to think about more of the game state. Maybe you have some attention mechanism. I would like to see a deep Q network try. But I think that between all of the different things that it has to reason about and all the different levels at which it has to reason about those things simultaneously and the long time horizon, it just seems like it would be tough for a deep Q network. It just seems like a huge state space with a lot of symmetries that aren't evident. You could probably get some mileage out of training a bunch of different networks on the different subproblems and then using some attention mechanism to try to combine those. But that's already a lot of domain engineering that's going into it. But I'm open to seeing that kind of approach for sure. I'm like a Yale School AI, build it to understand it kind of person though. So that's just not my approach. But I think that especially for the clue understanding, like the common sense stuff, to me that seems like places where like associative learning and word embeddings and stuff that's grounded in the like neural net business seems like it would be useful and helpful. I hope that was an okay answer.
We do have one other question on stream.
Okay.
Which is, sort of been answered, but do you think that this would be able to tackle extremely bespoke one-off mini-game things that appear in some RPGs? So the example they give is the one-off strategy game you play in FF7, for example.
Yeah, I think that kind of thing is really interesting. I feel like it's important to model the fact that those things can exist in a game. Actually doing the solving of it seems like you would probably have to fall back on GVG AI style techniques or direct search or something like that, because I'm not sure. They often introduce like not only new mechanics but new operational logics, like new ways of understanding things that are happening on the screen that just aren't present in the actual game. And I feel like if you wanted to be able to, in the same framework, address all these mini games, you'd have to be capable of addressing all possible games instead of just role-playing games. It's super tough. That's like often even in like boss fights or something, sometimes you see some like one-off mini game thing that's happening, and that kind of thing. Like I'm okay if it falls down in that situation and has to resort to something that's not like knowledge motivated in the same way that the other stuff I've been talking about is. Okay, thanks very much.
Awesome. And let's switch on over to our final talk before lunch.
I apologize in advance, like the mountain air is giving me pretty severe allergies, so I'm right now on the peak of both allergies and drugs, so hopefully this will go okay. Hi, I'm Kate Compton. I'm speaking on a project with myself and Michael Mateus. We're from the Expressive Intelligence Lab at UC Santa Cruz. So this is the generative framework for generativity. It's yet another framework for procedural content generation, but one of the things that's kind of interesting is it tells you what you can build. One of the motivations for this is it's now been about 9 years since Spore came out. I did the planets for Spore, and a lot of my 9 years since then has been trying to figure out like the lessons of Spore, how to communicate them, and a lot of the stuff people keep coming up with from first principles or working on a new game and only kind of accidentally finding out the things that we found out about procedural content generation during Spore. So I'm really just personally invested in getting tools that we can use to communicate. I do have a time on here. Getting tools that we can use to communicate, like how we build PCG systems, how we build any kind of generative systems. I used to be mostly in games. I've now wandered kind of out of games into like weird AI stuff. So AI for all sorts of different purposes. So this talk is not specifically about games. It's about kind of procedural content and generativity for all kinds of different things. So I wanted to start with this example because I found this on the internet and it was just so unbelievably dorky. So these are two examples of, the one on the left is somebody who has scanned their brain while contemplating the word comfort, and then made a couch out of those brain scans. The one on the right is somebody who scans somebody else's brain while having them think about different colors and shapes to identify what they would like in a chair, and then use that to design a chair. And the guy, for the record, decided that he hated the chair that was designed. So you kind of have something like this for these two generators. So these are two generators that are taking brainwaves and outputting chairs or couches or other sitting things. And we get a lot of these. You'll often see these if you review papers or if you write papers or you read papers or outside of academia, if you look into a lot of this sort of like interesting AI application stuff. We have taken blah and made blah out of it. And usually there's sort of a tangled, invisible black box in there. And how do you get from brainwaves to a chair? In games, we have a lot of this, right? I don't know if any of you have ever worked on or tried to play a game. It says that we're going to take your experience in the game and turn it into a level. I worked on a project called Charbitat back at Georgia Tech that was about like taking your experience during the game and turning that into levels. And it turns out there's a really tangled approach to like how, you can't just take the words your experience, turn that into a geometrical mesh, and have you play a level on it, although that would be one approach, not a good one. So often you have like a bunch of inputs and a bunch of outputs that you're trying to generate. So this project, this framework is trying to figure out a way to talk about when we have a bunch of inputs and we're trying to generate some sort of outputs, actually talking about the pipeline that we're using. There are a lot of generative frameworks out there, or frameworks for generativity. These are a couple of the ones that I wrote about in the paper. They're all good for different things. I especially like the bottom one. This is actually, because I'm outside of games, I get to see a lot of different generativity thoughts from different fields. And generative art is an area that is much more mature than the PCG community is. And so it's developed a lot more interesting thought. And so this paper, aside from being quite good in itself, also contains a 1.5 page breakdown of previous frameworks and taxonomies of procedural content generation for things like dance, algorithmic music, kinetic art, etc. In fact, like leaves and stuff. So they also analyze physical generativity sort of in the natural realm. So it's really neat to see that, like, if we're talking about procedural content generation and how do we think about procedural content generation, we can also look at other fields and how they look at generativity. I apologize for the formatting on this slide. This is one of my favorite books. It's out of print, but there might be a PDF somewhere in this room. But I really like it because it goes through nature and analyzes nature as a series of forces that are acting on things. So you can see kind of the chapters are like patterns and bubbles and waves and bodies. And he goes at scales from how the universe is made up to what soap bubbles look like to how viruses are put together, and finds kind of a number of patterns. So just forces that work upon anything that is naturally generating to create the patterns that we see. And I really like this because this kind of gives you a set of tools that you can socket together. Maybe there are a whole bunch of different things working on, like, that cause galaxies to be shaped the way that they are. But you can kind of break down the pipeline. So the project of this framework really, and why I'm not using the previous frameworks, which are good, and I encourage you to read them, especially if you're interested in the applications of procedurally generated content. They're often about what ways can procedural content be used in games? Can it be used as music or rule generation? How can it change or create gameplay? Like, how does procedural content make meaningful gameplay? Sometimes they're a deep dive into sort of a single-step generative process, like Togelis' search-based PCG. This particular framework, I'm interested in what are the basic components of generativity. Like, when we build generators, what can we use? And specifically, what are the inputs and outputs of those parts? And then, how can we chain those together? And then how can you use those big pipelines of information? So if I, in fact, have something that says, okay, if you have brain waves and I can generate a couch from that, so I have the couch to brain to couch pipeline now, can I use that in something else? Can I use the brain to couch pipeline in, like, a Twitch stream that is where your EKG is being recorded? So I've done this for a really long time. I did this professionally. I've done this academically. I've done this as an indie. And I found and talked to a lot of other people who make procedural content generation systems. It's very rare to have a finished ship system that doesn't use a whole bunch of techniques. Often we'll present it at conferences as though it uses a single technique, but there's also often a bunch of sort of like super glue techniques working around behind the scenes. And even toy generators are often, like, made out of a lot of stuff. By the time you actually get to something professional, so like something like No Man's Sky or Spore, you often have a giant network of techniques that are sort of operating layers. One thing generating a thing that generates another thing that generates another thing, and that thing is used as the input to another thing, and then the player does something, and that action is used in another thing. So think of Dwarf Fortress and how many layers Dwarf Fortress has. And then remember that that's 2 people, and we also have like 100-person PCG teams working as well. Kind of the other thing that I want to talk about is that there is no pipeline or generative part so small or uncomplicated that it's not interesting to use. So you probably wouldn't see these 3 things on the right as part of a PCG talk. Like, all right, it's a dice, a magic 8-ball, and a Ouija board. Each of those things takes something and generates something with it. So a dice generates me a random number. Magic 8 Ball generates me a string of text. A Ouija board takes kind of the forces of two hands and generates text. So these are little sockets that we can use. We're basically building up, the goal of this process is to kind of build up a giant set of Legos, such that, if there are a lot of games that take a string as the random seed to do gameplay. I think RimWorld does that. So you type in your string and it uses that to generate your world. What if you were allowing the spirits to move your hands that would generate the string that would generate the random world? You can once you have these Legos, you can switch the sockets really easily. So yeah, a little bit about the project of this framework. Okay, cool, I'm still going on time. This actually all started when I was asked to give a talk to a generative music class. And the professor said, oh, just give a talk on what PCG is. And I was like, oh, that's cool. And I was in my second year of grad school, I think. So I was like, okay, well, what is PCG? And I started writing the talk, and I got to the what is PCG slide, and I pretty much stopped there. And it was really hard, because I couldn't think of what is procedural content generation. And I ended up taking a bunch of people out to drinks one night, putting a bunch of things on little Post-it notes, like Conway's Game of Life, Pearl and Noise, Spore Creature Creator, and asking them, raise your hands here. Who thinks that Conway's Game of Life is procedural content generation? So about half. How many people think that Pearl and Noise is? How many think that the Spore Creature Creator is? Yeah, so that one had most people, but most of them had about half the people. So we're really unsure what procedural content generation is. So I worked with Joe Osborne, who just spoke, and Michael Mateus to try and make a paper about what is procedural content generation. And then I also wrote a blog post about kind of what are the big categories of tools that you can use to build generators. And that did very well, and I gave a talk at GDC that went over very well. And then the latest project is this framework and the Generominos. And what's kind of shaken out of here is that when I want to figure out how so these are kind of the issues that I'm trying to deal with, or that I'm trying to solve here. How do generators work? If I'm looking at couch generators, what does that have to tell me about an RPG maker? If I'm looking at RPG maker, what does that have to tell me about a music generator? And then specifically, how can I expand, modify, improve, or reuse generators? So how can I look at something that seems like a boring generator and make it more interesting? Or how can I take something like Spore, or the Spore Creature Creator, which worked very well in some different ways, and say well, now I want to use that to make generative music. How am I going to take that apart in a meaningful way so that I can get those same effects? So yeah, part of this is, after I figured out that procedural content generation, the part that I'm interested in is really the generativity, figuring out what generativity is. So this is the definition that's useful for my work, and I found it very productive. It's successive data transformations with each transformation either generating, transforming, or pruning away information. So I have some data, whether or not that's a random number or not, and then I'm using that to generate 15 random numbers, which I'm using to initialize a height map, which I'm using to do a thing, and then eventually I get a nice terrain out of it. So I care about the data and the transformations. This framework doesn't tell us how generative or transformational something is. So it won't actually tell us how interesting those brainwave to chair generators are. But it does allow us to map out the entire length of that generator and say, this is where you are pretty much throwing away all of your data and using it as a random number generator. So you can point at moments inside of a generator. It doesn't tell us the appropriateness for the purpose. I don't personally think that either of those things make particularly good chairs. And it doesn't tell us how the end products will be used. This is especially important in PCG, where you're generating content for games. And I can generate lots of Mario levels, and many of them will be very bad for playing Mario. However, this is the generative framework for generativity part, or the GFG, because I got tired of typing it out. It does give us the space of what will be built. So if I have a whole bunch of Legos, and each Lego has input sockets and output sockets, I could say, give me a map of every possible wiring of everything that can take a random number, socket that on there, and then everything that can take the output of those things, socket those on there, and tell me what can possibly be built. I don't have unless I have a brainwave to couch part, I can't just say, this thing takes brainwaves and outputs couches. I have to have some number of things to build the pipeline in between. So yeah, I wrote this paper because this paper was actually used to be a single paper with the Generative paper that I'll be presenting this afternoon, because the idea was to actually physicalize this thing, to give you a physical set of little Legos that you can socket together and see what you can end up building into a generator. But I did end up getting a whole bunch of categories. And interestingly, as I was trying to categorize things, this split into two different things. So there's sort of, these are your Lego pieces. These are your things that take some data and turn it into other data. So you can imagine like a Perlin noise function where I take an X and a Y and I turn that into an interesting number. Or I do sentiment analysis. I take a string of text and I turn that into a number of how positive or negative it is. And then there's kind of a whole other category of things. So like I've seen a lot of the other frameworks kind of lump all these things in together. It's like, oh, what kinds of procedural content approaches are there? Well, you have grammars and you have search-based. And it turns out actually this whole set over here requires a pipeline that you've built. So each one of these requires you to have built a pipeline. I'll go into that later. But yeah, just a quick run through these categories of transformation. You can also get a lot of the similar information from my GDC talk or from the giant blog post, but I've kind of been iterating on this. So yeah, and part of this is also to remind you that there is no part too small to build into a pipeline. So something like content selection. Michael Matthias has been talking about this at our lab a lot recently. So content selection, how do you choose which line of dialogue a character should say? And there may be lots of interesting rationale for that. You also might roll some dice. I really like these because it shows you what you can do with content generation. This is a Pinterest board of tarot card spreads. So this is like you're generating content by having one of these spreads, flipping a tarot card into it, and then based on the content that has been randomly selected or selected by the fates or selected by the hand of fate or whatever, you can then read meaning out of it. So you can have randomness, or you can also have much more sophisticated user modeling techniques to figure out what content you are. So yeah, which Disney princess you are, or which Mario difficulty setting you would like this to set at, whether or not you believe that is more or less sophisticated than the Disney princess quiz. And yeah, you can use this for all kinds of different things. These are recipe dice, story dice. There's sexy times dice, which I did not put up a picture of, but you can have various generative content that is really just rolling two things and then looking at the juxtaposition. And for all these categories, I kind of break them down, especially in the paper, to things that they require and things that they return. So this is what are your inputs and what are your outputs, because this is how you're going to build your pipeline. So content selection is really good at you have some content, pick one. And maybe some content and a player model, and you pick one based on that. Tiles, we use tiles a lot. We've seen tiles actually a couple of times already today. You have a bunch of tiles, and you're going to socket them into things. So obviously in board games like Betrayal at the House on the Hill or Catan, we see actually physical tiles. We also see them digitally, so things like Dwarf Fortress and Rogue. But you can also use them in any situation where you have sort of a space of a fixed size and you are fitting something into it. And so it's neat to remember that this is not always just spatial. This is not always just a game level. This is a falsely attributed to Mozart dice music game where you can imagine now a sheet of music that each bar is an empty socket, and you can socket some music into that. And of course, you use your content selector of a dice to pick out which music you're going to select. You string that all together, and now you have a generative polka in 1760 or whenever this was made. And of course, things like Diablo-style tile generation. I'm sorry that this is so very dark. This is a really excellent site that has gone through all the different socketable components in Diablo 2. So you can kind of see that A over here is the same piece as A over here. And so there's actually a grid that's being made, and the way that the Diablo 2 levels are generated is you put a piece down, then you fill in the next socket, then you fill in the next socket, then you fill in the next socket with the pieces available. Of course, you can't just put everything next to each other. There are corridors off of one side or another, so you actually have to use something like a grammar, which says, okay, if I've got some number of sockets and some number of replacement rules, give me kind of a tree of the recursive choices. And you can either do these shapes or sort of text grammars. Ask me about tracery if you want to know anything about text grammars. But even these things that are like, yeah, I have a grammar and I'm going to just generate something. It's easy to forget that these are also pipelines. So a grammar is not just press a button, get a thing. There's actually a grammar that is going in as input to that thing that is creating that output. And so if you stop looking at this as like a single PCG unit and start saying, oh, this is something with an input, over here on the right is something that I made. It's a language generator that then generates poetry in different languages. There is a generator which generates grammars, and then those grammars go into this thing. So you can have grammars as input to other grammars, and then use the output for something. You can also have the output of these grammars be a specification for something. So Joris Doorman's work uses grammars to generate level maps, and then uses a variety of other PCG techniques to take those sort of graphs of connectivity and turn them into something that you could actually play a game about in his unexplored game. Parametric, this is one of the most common ones because it sockets so damn well into things. Sorry for swearing. So parametric stuff you might be familiar with, like, so here are some flower generators that I made, and here's, over on the right is kind of the animated version of it, but over here on the left is what's actually going on behind the scenes. There's an array of like 32 different values, and those 32 different values make a nice little L tree flower. But you can socket this into anything. So invisible up here, I've actually got it socketed into music. So if I have music broken up into frequencies, that I can say, okay, well, just map each frequency to a value of the flower, and suddenly the flower starts dancing along to the music. I can say, okay, well, hook that up to leap motion, so I have a leap motion. Hook that up to where my fingers are, so now I have a flower that as I wave my hands, the flower starts shifting. This is just kind of an example of, like, you have the parametric stuff is like the USB of procedural content generation. You can just plug it into anything, and it allows you to plug stupid things into other stupid things, and sometimes it's a good idea. It's also really useful as what is it called? Genetic algorithm. So over on the right, it's actually being plugged into a very slow human-selected generative algorithm. Geometric transformations are a bit of a sort of everything bucket. This is just when you have some interesting shapes and you're using them to make other interesting shapes. So this is a bunch of examples of what you can do with, I have a curve. So my input is a curve. The user has drawn something, or I've detected that the user's arm has moved somewhere. In IOBrush, this is a fairly vintage one, you have pulled in some data from somewhere else that's an image, and you are now extruding that along a curve. Here's civilization. The roads and the Great Wall of China are all paths that then have interesting geometry extruded along them. Tilt brush is all about extruding geometry along different paths and having different sort of animated geometry, or geometry that is offset, or geometry that is multiplied in interesting ways. This one at the bottom here is called Travels in Odd. It's a little train game that I made. Why should you actually generate terrain? Just make a curve that the train is going to follow and put some terrain along that curve. So using a curve, so these are 4 different ways of using a curve to create some generative stuff. Where does that curve come from? Some other method. This is something in The Sims. or SimCity, I would recommend. This talk is really, really good and breaks down in incredible detailed system of how the recent SimCity actually works. And it is just layer upon layer of every different PCG technique, all working as a giant symphony. They break it down beautifully. Distributions, this is one of the first ones that everybody does when they do PCG is, I have a thing, put a bunch of that thing on the screen. And you, of course, can do random select, just put things down randomly, or you can say cluster it in different ways. You can say, have a probability-based distribution of height maps. But you can also have all sorts of different aesthetics. So greebling is where you put a bunch of stuff onto something to make it look real. So just cluster a bunch of things and it'll make it look more real. That's actually a term from Star Wars. Ask me about the history, it's funny. Footing. If you have an object stuck into another object, there should be a bunch of things around that object. Look at what dirt does around a river, like there's a whole different like array of effects. And if you just stick a river on some dirt, it looks stupid. And similarly, barnacling, if you have a large thing, it's often surrounded by a bunch of other smaller things in some way. And so this is like, distribution is just, it seems like a simple technique, but you can also have a whole bunch of other things that feed into it. So when you're kind of using this as a socket, you can say like, what is going to feed into my distribution? Particles are my favorite just because I freaking love particles, but also cellular automata and kind of all these simulation-based techniques. This is a flower generator that is using the physics forces on those little particles to draw curly flowers. And this, there's a whole bunch of different things that can feed in, but you get kind of these trails out, or you get the new state of graphs. This is how we did the terrain in Spore as well. And like I said, I freaking love particles. So these are a bunch of different things that I've generated with particles. A really fun one to use is Boids, because Boids, you think of them as, I'm going to use a Boids simulator that's going to generate a flock of stuff. Well, what's the input to that? It turns out that Boids actually has 3 kind of magic values of how strong the alignment is, how strong the cohesion is, and how strong the one that I always forget is, separation. And hey, you've got 3 numbers. What can you do with those? That's a parametric generator. Let's make an evolutionary algorithm. So you can make a little evolutionary algorithm flock generator, which I did down there. You can also have particles obeying physics that come from interesting sources. So the one on the bottom right is face tracking that is moving particles, and the particles kind of make this fun rainbow beard that wanders around. And then the one at the top right is doing procedural dance generation by applying music-based forces to particles. So all these are the same technology, just I'm socketing different things into those particle simulations. This is one of the ones that's pretty fun because we're not really sure what to do with machine learning in procedural content generation yet. We're really good at saying okay, here's a corpus of stuff, feed it in, get another one of those corpuses. And you can kind of turn that crank for as long as you want and get a paper into ICCC and a bunch of other things. It was there was a really good one about feeding all of Chuck Tingle's work in, and you get more Chuck Tingle out. But where is that corpus coming from? And where is that? So one of the things you can do is having this kind of deep dream stuff, where you give it the sort of learned rules, and then you give it a piece of source content, and you say what would these rules make of that content? So here's one where it's people hand draw things, and then it applies a catification algorithm and turns those into horrifying cat pictures. Here's Alex Champadard's slightly more functional version of that, where you can draw things. You can kind of MS Paint your way to a Chagall painting. And yeah, this one is kind of neat because you actually get 2 different kinds of Legos out of this. As I was trying to think of what is machine learning actually doing? So you have one Lego that is okay, I'm going to take a lot of content and I'm going to make a model. So you have your input of lots of content. Where is that content coming from? I don't know. Find out. And then transformation via model, where I have a model, wonder where that came from, and some other content, and then I'm turning that into something. So now that you know that this is a tool, figuring out where you want to use that tool is interesting. I won't go into consumers of pipelines very much, although this is super interesting and ask me more because I'm really excited about the last one. But for example, genetic algorithms are a really great consumer of pipelines. So it turns out if you're writing a genetic algorithm, you actually need 3 pipelines. And how are you going to build those pipelines? With those things that I just mentioned. So you have some DNA, and there's a pipeline, and then it gives you an artifact. So maybe I have a parametric flower generator. Maybe I have something else that's using grammars or something. If I have another one that takes an artifact and gives me an evaluation, maybe that just says ask a human. There's just one big card that says ask a human. Maybe there's another card that says simulate this in a Mario-based runner. Doesn't matter as long as you have a pipeline that has artifact in, evaluation out. And then you need something that takes a DNA population and the evaluations and gives you a DNA population out. You can do all 3 of these totally independently. So this is that kind of reuse thing. You can take somebody else's thing that seems to be working well and say instead of making flowers, I would really like that thing to be making 3D landscapes. Instead of 3D landscapes, I like it to be making cars. Instead of having the user pick their favorite, I would like a simulation. And so you can kind of shuffle these around. I like your genetic algorithm, but I really want it to be doing crossbreeding, so I'm going to fix the one on the right. So you can kind of just swap things out. Yeah, interactivity, this is my favorite just because this is my dissertation. So here are 2 different flower generators, one by Ken Stanley's group, one just by me that you saw earlier. And they're both, user picks their favorite. This one is like multiple weeks of slowly growing your flowers to find new flowers in the flower space. Mine is you're clicking very quickly. You get different kinds of effects from there. The one on the bottom right is your, so remember all the things you can do with curves? What if you have the user just like continuously drawing a curve, and then I'm continuously generating based on that. So rather than saying like curve goes in, stuff goes out, it's just a continuous feedback loop, and you can get a very different effect with continuity rather than kind of a one-off push button. Constraint solving. Constraint solving is kind of an interesting one because it's like really easy to not think of the inputs to constraint solving. Like you write your constraint solver and that takes like 3 years of your dissertation and then you're done. Darn it. But you can actually like use inputs of constraint solvers as gameplay. So this is a little game that I made that did not work out terribly well, but the user is writing ASP constraints and feeding them to an antagonistic AI who's going to allow you to move around an island or not. So like suddenly like AI constraints are the thing that you're like that the user is making. So yeah, just kind of a quick example of like why is this a useful thing to have? I like it because it allows me to generate new stupid ideas for generators, which I then build. But yeah, so Spore and No Man's Sky, they both make terrain. It's really easy to look at their terrain and say, okay, they're both going to take a random seed value and create a terrain to put under some procedurally generated characters. But they're actually totally different systems. And ask me more at any point. I love talking about both of these systems. They're both really awesome. This one was a terrible idea. That one was much more functional, but they're both really interesting. But they use totally different sets of the tools mentioned before, where the Spore one was almost entirely particle and curves based. This one was entirely voxel and Perlin noise based. And then use the voxels and how you can't play a game on voxels, so you're going to have to turn that into geometry. So they had a whole thing to turn voxels into geometry. I guess the main point from this framework is that you can never have a magical transformation. A lot of PCG systems fail because they have a cool input and a cool output, and there's no way to get from one point to another. Or you have to go through a really bad idea to get from one point to another. You can always take your data, throw it away, put in a random number, and then continue going. And a lot of systems choose to do that. And it's fun as a reviewer to try and find the systems that do. But you can also use this to analyze systems and how they're different. And yeah, just revisiting those old chairs. The one on the left takes your brainwaves, uses that waveform time to make a height map, which is a geometric transformation. The one on the right makes an array of numbers, selects some content, and then I will hopefully they did parametric chair design, but I suspect they just had content selection where they're like, if this number is high enough, choose this chair. If this number is low enough, choose this color. And yeah, future work. I've encoded these into the Generamas, which I'll be telling you about later today, and you should totally come play with them because as far as I know, this is one of the first physicalized frameworks for PCG. And yeah, any questions? Although I think we're probably at the very end. Yeah, this was a quote from Ines McKendrick's talk during GDC, which was basically detailing the entire mad pipeline of what goes on in the terrain generation of No Man's Sky. And he said, yeah, no, you just keep throwing more functions onto it until you get something that looks interesting. But you need a lot of functions to throw. Do we have any questions from the feed? You could just, yeah, I'll repeat it.
So this is really cool. I've seen it before, I think it's still cool. So what about for things that aren't just, so you gave the example of the 2 different flower generators that are in this sort of model, sort of the same thing, but they're very different in terms of the aesthetics that are going on. Is there any way that you can model that as part of it?
Not yet. I haven't figured out a way to describe. Oh, so the question was for those two flower generators. They're different. They're very similar according to this framework, but they're very different aesthetically. Is there a way to model that aesthetic difference as well? So I guess both of them are very similar in their inputs and outputs, and then in the way that they generate those flowers are very different in the pipeline. So I think theirs uses like recursive neural nets in some funky way, or like some combination of functions, and mine is like much more of an L system. And I guess that's one of those things where like it helps me to have the pipelines laying out because I can point at the L system and say, the L system gives me a lot of control. And these machine learned methods don't give me control. And so I can have a lot more control over the aesthetics, which is why my aesthetics are more tightly tuned than their groups. They can have a wider range of possibility space because they can actually go into higher dimensionality. Yes?
So I'm curious, one of the problems I run into with generative systems is they give you a huge range, but then you have to select from them. So we do a lot of work with evolutionary algorithms, genetic algorithms, to sort of sort amongst them. And then there's sort of human-based selection. Have you come across other ways of sort of limiting the output in a sense?
Yeah, so the question was about limiting the output of these generators or filtering the output in some way that, you know, there's search-based and then genetic algorithms and then there's human-based. I go into this more in the paper, so you might be interested in that. But yeah, there's lots of like automated search-based ways. If you have a heuristic, basically if you have the magical socket that says, give me an input and actually evaluate the output and give me a number, you can use that to do a bunch of the search-based techniques. And then the human ones work well if you're not trying to get the optimal technique, but that actually makes, like, there are pleasurable ways of searching for input or searching for interesting stuff in the generated output, even if the generated output itself is kind of rubbish. People seem to enjoy exploring that space. So two very different sort of approaches depending on what you need the content for. Okay, and I think they're going to cut it. So thank you.
So at this point, it is lunchtime. As far as I know, lunch is not provided by AIIDE or anything, so y'all on your own. We can talk about that offline.
And we will resume at 2 o'clock.
So in about an hour and a half,
Yep.
if you're worried about time zone conversions.
Yep.
We'll be cutting streams, which means a new stream URL. So see you all soon.
Yep. See you back at